Welcome back to the Decarb Connect podcast. I'm Alex Cameron. I'm the CEO and founder of Decarb Connect. And today I'm talking with John Bissell, who is the co-CEO, which is a job title I definitely want to come back to, John, and founder of Origin Materials. Now, Origin really kind of piqued my interest because they are focused on developing carbon negative materials and specifically new materials within the chemical sector. I hope I'm framing that in the right way, but I'm going to ask John to give a bit more of an intro and perhaps ask the question that I always ask to open the podcast, which is, how have you arrived here at this point in time, both personally, but also professionally? And also the co-CEO, how does that work?
Sure. Well, the short answer on co-CEO is that he and I basically allocate the areas of the company to each other that we feel like we have a disproportionate advantage in running. And so it kind of works out that he takes the revenue side and I take the cost side. Doesn't split quite down that line, but it's pretty close. But we actually work together really well. So it's extremely uncommon for us to have something that is not an almost immediate resolution to our sort of difference of opinion. And usually, if it's not immediate, it's a few minutes of discussion.
And how long have you guys worked together?
So he's been an investor in Origin, was how I met him, since 2010. And I worked with him reasonably closely as a result of that for a long time. And then he's been co-CEO with me for a couple of years now. So we've got some games under our belt at this point.
How did you arrive at this point in time? And I love hearing both that personal story as well as the origin story as well.
Sure, yeah. So I'm a chemical engineer by training, and it oddly enough, it turns out that's sort of a family practice, but not in my generation or my prior generation, my family, but the generation before that had. My grandfather was a chemical engineer, which I didn't appreciate until after I'd become a chemical engineer, which is kind of fun. I didn't appreciate it because he ended up also being a doctor. So who's both a doctor and a chemical engineer. Everybody else in my family is a doctor, sort of speaking loosely. But so as a chemical engineer, there are a couple sort of canonical disciplines that you pay attention to, or industries that you pay attention to. You're sort of taught all of chemical engineering as a result of oil and gas and commodity chemicals and materials. Those are sort of the two big ones. And then, pharma gets kind of tacked on the side as a by the way. And so for me, it was always sort of obvious that if you could make a big change in oil and gas or chemicals, and for whatever reason, the energy side of oil and gas never felt like the obvious application for oil and gas. It was always the material, is the physical goods part of oil and gas and chemicals that was interesting to me. And so it felt like, well, obviously, if you can make a big difference there, then that's going to ripple out to the rest of the economy in a really meaningful way. You don't have to sort of trace exactly what the change, well, I'm going to change this plant, which changes this good, which changes this thing. You can sort of look at it in a more gestalt kind of way, right? And say, if I can change oil and gas or how that's done or how commodity chemicals are done, then that's going to ripple through all of human society in a really positive way. So that was sort of the starting point, which in some ways is a little bit, in retrospect, is a little bit naive. As a chemical engineer, if you're going into, if you think you're going to change the technology associated with oil and gas or commodity chemicals, I don't know, it's kind of like saying you're going to grow up and be a fighter pilot, right? It's like what every chemical engineer wants to do, I think, if they think about it. And we were just, so my co-founder, Ryan, and I were just sort of stubborn enough and tenacious enough that we started down that track and we never let go. And in the process, we kind of, in a somewhat routine kind of way, kept saying, well, okay, what do you have to do? If you're going to go make that big change, well, you're going to have to build big capital projects. All right, well, what do you have to do if you have to go build big capital projects? You got to go get the people who know how to run big capital projects, and you got to raise a ton of money. Okay, let's go do that. It's just like chunk, and then eventually you get to a point where you look around and you say, geez, I think we might actually have a shot at this. So that was sort of the background. And frankly, the history of the company is kind of like my professional history, since I started it so early in my career. Those two are effectively synonymous.
I love that description, the kind of tenacity and determination. I mean, I think so many people ask entrepreneurs, like, what is it? What's the thing? And it's like, it is that. It is that.
Yes.
It is just putting one more foot in front of the other, even when it's hard, and getting it done. And that's what really is the competitive advantage, isn't it?
Yeah, I sometimes describe it as naivete and chutzpah.
I think I've described it as bloody-mindedness and tunnel vision, but sure, it's kind of somewhere in there.
Tomato, tomato.
So when was the point in the development of Origin where you really felt, okay, we're now on to something and there's real potential here, it's feeling real? Was there a moment in time where it kind of started to click?
Well, there was, I think there was the moment when we intellectually felt that was the case, and then there's the moment when we sort of in our heart felt like that was the case. And I think we were more correct with the intellectual one than the in our heart one. And the reason for that is that the chemical industry, and this is true for I think a lot of quote unquote hard to decarbonize industries, but the chemical industry is extremely complicated and complex, both. In the sense that if you're going to be a successful chemical company, you have to be damn close to world class at so many different things, so many. And so when we were as a startup, that's really interesting, because often startups can just be good at one or two things, and they can sort of carry themselves all the way through to solve everything else. And they can be bad at other stuff for a long time. And you can't quite do that in the same way in the chemical industry. You can do it, but it doesn't look like that, right? What it looks like is I don't have to be good at everything right off the bat, but I have to make sure that I'm operating in a way knowing that I'm not good at that thing yet. And I will be good at it someday. And so as a result, we sort of sat down and said, okay, well, what are the capabilities we need to have at each stage of life? And which ones do we need to be good at? And which ones can we be bad? And which ones can we just not do? And, of course, the technology is the part where you have to drive certain kinds of certain elements of the chemistry forward early, because if you don't, you sort of don't have a reason for existence. And so that when we got some of the early results, that was, I think, when we said, wow, we've really got something. We were seeing really high selectivities and good enough conversion. That was sort of the combination for us on that particular step. On one of the steps of chemistry that we'd written down ourselves, we said, okay, well, we think it's going to go like this. And it was pretty odd chemistry. It was actually the last step of conversion for our synthesis of paraxylene, was like wholly invented by us. It was actually a sort of combination of chemistry that nobody'd ever done before anywhere, and arguably was, it was not like, oh yeah, well, of course that's going to happen. People would look at it and go, yeah, I'm not sure that's going to work the way you want it to, and then it did. It worked exactly the way we wanted it to. Incredibly, super high selectivity, and so when we got that, which was in 2010-ish, was when we landed that, I think. We said, boy, I think we might have this. Now, the journey after that was still very long and very stressful, and very, there's all sorts of things that, at that point, we were basically the guy who's now our chief scientist, Maka Masuno, my co-founder, and me in a lab. And I'll tell you, my co-founder and I were a lot less useful in the lab than our chief scientist was. So a lot of the time it was like the two of us talking about what the experiment should be while our chief scientist actually did it. The three of us together, or analyzing data or something. But that was the moment. But after that, man, there's so many times where you've got to bring on another capability, capital projects, whatever, right? And you say, boy, and if I can't bring that on right, this is going to get ugly. And so then you go through that whole process all over again, right? Which is like, oh, am I going to be able to do this? I'm not sure. And then you get the moment where you say, oh yeah, no, we got this. We got it. We're going to do that. We're going to do this just fine. Then you do it again about 4 months later.
A million times.
Yeah, right.
So, for those people listening who aren't familiar, could you just give a kind of quick feel for? We'll talk a little more, obviously, about the company as we go, but just a quick feel for the sort of examples of clients and the types of material that we're talking about, the type of product, effectively, that we're talking about.
Yeah. So there are a couple ways to describe it. Sometimes I call it organic materials, which is sort of a useful characterization if you're talking at the top level, because there's the corollary being, well, if there's organic materials, there's metallic materials, which are somewhat more obvious, right? Like aluminum and steel, et cetera. And there's ceramics. And ceramics are everything from cement and concrete to glasses or some of the more technical stuff in between. And so sort of in a really general sense, we're getting after all the organic materials, which is polymers and solvents and paints and coatings, right? All that stuff, fibers. And now, of course, those are not all one big lump, not really, right? They're each individual materials with very specific technical performance specifications. And so what we do is we actually operate even deeper in the supply chain or the value chain, where what we're doing is converting lignocellulose or woody materials into intermediates. Those intermediates can be used to make all kinds of different things. The intermediates that we make specifically are chloramethylfurfural, CMF, and hydrothermal carbon, two very different things with different product slates. And we have to make both for the most part. And so sort of like going back to the oil and gas stuff, it's sort of like refining, right? You sort of have to make to a certain extent, a reasonable approximation. You have to make asphalt, and you got to make naphtha. And everything, you can sort of shift it one direction or the other, but you got to make both. And we're the same. The way chemistry works, you got to make both. So, but those intermediates can be used to make all kinds of things. They're very chemically flexible. They're new, so they have new structures in them that haven't really been available commercially before. But they're close enough to a lot of what's out there that we can actually sort of steer them into existing markets too. So that's what we do. We convert lignocellulose into chemical intermediates that can be used to make all kinds of different materials. And ultimately what that gives us is carbon negative or low carbon materials, depending on exactly what we're making. And in a different, in a sub bucket there is, they're all low carbon or decarbonized. Some of them are the same as what people make right now, but decarbonized. And some of them are completely new materials that people have not really had access to before. But they're decarbonized. So that's our business.
We'll come back to that because I have a question about how much education of potential clients is needed to kind of, especially I guess in that new product area, but we'll revisit that in a little while.
Yeah.
So I have sort of 3 or 4 key questions, but before I dive into those and they're more specific about your experience and the way that the business has come to be, I have a broader question for you. So it's the start of a new year. Everyone, I think, involved in industrial decarbonization would admit or agree that 2022 did not pan out, for better and for worse, in many of the ways that anyone would have predicted in January last year. Whether it's Europe and gas prices, whether it's the States and policy at the end, I don't know, all kinds of things materialized and happened that maybe weren't expected. But for you, when you look at the year ahead, what's your gut feel about what's going to define the work stream or the workflow around industrial decarbonization as a whole? I know that's a massive question. I'm just interested in what trends or what decisions you think are really going to prove to be pivotal in the next 12, 15 months.
I think there's sort of a transition happening, a good one, a necessary one, which is I think companies, at least in our experience, companies are starting to come to grips with the numbers of decarbonization for themselves. So I think I still think there's a lot of work to be done in standardizing, or maybe just saying agreeing on the way that we measure decarbonization. But I think we've made a lot of progress there. Enough progress that people, in our experience, or companies can look generally at their carbon footprint and where it's coming from. And the numbers are good enough and tight enough that they're not disputing them, right? I'd say 5 or 6 years ago, they'd get an LCA back and they'd say, it's not real, right? And they would take use that as justification to take no action at all, right? Oh, they can't even figure out what the numbers are. Don't even think about it. And I think we're way past that, usually. And I think the transition that's happening is people are starting to look at the numbers and think, for, in some cases, sort of the first time, seriously about what it means to go address them. And that's a good spot to be. And of course, there are leaders and laggards on all this stuff, right? So there are plenty of companies that are way past this point and have been for 10 years, and we work with some. There are also companies that are still at the point that they haven't even done an LCA. We work with them too. But there's, it seems to me like the preponderance of the market, at least the Western market, is saying, and actually beyond the Western market, is saying, what are we going to do about this? What are we going to do about these numbers? Because they're really tough. And I think, and this is earlier, but I think people are starting to say it's not going to be easy. And that has a whole additional set of decisions associated with it, both at a company level and a society level. So I think people are picking up nuclear again for the first time in decades. And they're doing it for two reasons. One, because energy independence matters a lot more than everybody thought it did 2 years ago. And for obvious reasons. And also because I think people are realizing it's going to be really hard to decarbonize without nuclear. It's going to be really hard. And that's, trade-offs like that, people only make them once they feel like they have to. And I think people are in the spot where they're starting to feel like they have to, which is good.
Yeah, I think that's an interesting way of framing it. We certainly see, like, the conversations we have now and the conversations we overhear, at events or in any meetings we're having, they're a lot less about the, well, is it even plausible? Is it even, we don't really hear that. We did in the first year, I would say. But now it's very definitely about, there's a lot of a strong sense that this is happening already, and that for many of our customers, it's like the collaborations they're going to make are going to define whether they're going to get anywhere near their 2030 goals or not.
Yep.
So there's this kind of mad scurry, well, not mad scurry, that's not the right phrase, but a real kind of hunger for good collaborations, both between industrials and obviously that more traditional sense with suppliers. But yeah, the collaboration is the defining thing at the moment, is very much the conversation we hear.
It's almost like 2020 was the year that everybody recognized that there was real risk. 2021 was sort of the, okay, well, if there's real risk, I guess we have to decide that we're going to do something about that risk. And then it hasn't been far enough past 2022 yet for me to think seriously about what 2022 was, but it was in there somewhere.
So you've talked a bit about this reality that people, are putting in place numbers and metrics. They are sort of starting to really understand now the kind of the next set of challenges, which is how you make that real. So one area we hear a lot about, which is clearly where a company like Origin comes into play, is this sort of anxiety/interest in the materials being used across supply chains. Now, obviously, this is where you guys come into play. But I'm interested that when you hear from a customer or a prospect, like what is the challenge that they most often bring to you, or what's the question, or another way of looking at it is, why do they walk in the room when they do? What is it that has brought them to your door with that in mind?
So it depends on the product that we're dealing with. So that's just because they're different industry. When we make carbon black from HTC, that's a totally different industry than when we make paraxylene going into polyester, right? So I'll speak a little bit more to the PET side, but I'll try to be general too. So often they're looking at the materials side and they're saying, I have no idea how I can keep effectively the same product and decarbonize it, because they usually don't have any control over the way the materials are made. And that's sort of the key is, they have to go to an oil major, right? If they want to change the way that the materials are made, like that's the option. And I'll tell you, there's almost nobody in the world that's a big enough customer that they can drive an oil major to do something they weren't going to do already, And so materials are interesting because they even if their immediate material supplier isn't an oil major, everybody behind that guy is. And it's just really hard to change it. And even if, hypothetically you had a willing supplier, they often don't have the capability. They either don't have the technology, because there's real technology things that have to be done in materials in order to solve these decarbonization problems, or they don't have the financial wherewithal, right? Because the capital assets are huge in the materials world, or they don't have the organizational flexibility, right? So a lot of these legacy companies are set up in such a way that they can't take certain kinds of risk, and so again, going back to the oil and gas world, and chemicals too. Well, chemicals is actually it's an even easier analysis. They're just not set up to develop commodity scale technology in the way that you have to. So, for commodity scale materials technology, you're talking about 10 to 20 years of development time and $100 to $200 million of just development capital, and something like that depends on what you're doing specifically. And there really aren't human beings inside of the big chemical companies who can sponsor a program like that. They're not organized in such a way that there's a person with enough political will, so it doesn't happen. And so there's a version of that that's true through the whole value chain. And that's why it hasn't. I mean, the chemical companies and the oil and gas companies are filled with brilliant, hardworking people, some of whom have a real mission desire, right? And by the way, those people tend to end up joining Origin, but they're stuck. That the companies were not organized. I mean, look, if you've got a 2 to 4 year tenure, and the project is going to be 10 to 20 years, and you're trying to get promoted all the way through, what's your incentive? It's not to see the project through. Structurally, it's very difficult to see these projects through to the end. I mean, there aren't that many, we don't have 1,000 chemical company shots on goal to figure this out, right? There's only a handful that are big enough and have the right kind of resources to do it. And so you just can't really expect it to happen there. It has to happen somewhere else. I think that's true for a lot of the big industrial technology spaces too. They're just, if you really run the traps on, like, how are they going to do it? The answer is they're not going to do it. It doesn't look right,
No, years ago, I mean, really many years ago, I worked in a kind of sector of business intelligence around pharmaceuticals and biotechs at that point, when the kind of the acquisition or funding of biotechs really was ramping up the agenda for a very similar reason, because the big pharma guys at that point in time were not going to make the $1 billion bets in enough numbers to secure a future pipeline. And it was much easier in some way to kind of basically acquire technology as it had got through different levels of testing. And I suppose that's where we are in decarbonization.
I think that's exactly what's happening in what I'll call broadly sort of materials technology. Now, I don't know if it's going to happen the same way where you end up with an acquisition, sort of, because pharma was very specific about their desire to do that. But I think what you're seeing is the R&D, right, is moving out of the big chemical companies and big materials companies for the reasons that I just mentioned. And then you get to ask the question of, well, if that happens, then what next? Because I think while the pharma analogy is correct, I'm not sure that the logical next step is acquisition. It may be.
Well, on that kind of, just going back into what it's like to talk to those prospects about what they need, and we've heard that what they need is products that won't be made elsewhere, bluntly. I'm kind of also interested in how much do your prospects and clients initially understand, like what level of education are you having to take people through for a negotiation to kind of be fruitful, useful, or maybe none? Maybe that has been a big shift in the last couple of years too. But I just wondered, how much do people get about what carbon negative means? Quite simply, what are you encountering across the table in those conversations?
Again, wide gamut, right? The there are definitely companies that come and they're prepared. They know exactly what they want. They know exactly what they need. They know how much they need over what time frame, what the transition needs to look like for them to achieve their goals, right? No question. And I'd say there are a lot more of those now than there used to be. There used to be like one of those. And now there's a handful. We also see the other side where people come and they say, we buy a lot of PET and we're pretty sure that we need to change out that PET if we're going to decarbonize, but we're not really sure how much PET it is. Can you tell us? Can you guys figure out what the carbon footprint of our PET is? Because we're really not sure. That happens too. That's less common these days, but that's all right. Different businesses also have different levels of legacy knowledge about their supply chain. And so that's a big part. What was your starting point and how well you understood your supply chain matters. But I'd say more often people or companies come to us and they know that they need to swap out an ingredient, right? Or a material. They know that it's a large contributor to their emissions profile. They don't know exactly how they're going to do it. They're often open to new materials, not just decarbonized drop-in materials, but they're not sure how they're going to do that either. And so that's, I'd say, the most common is we know our volume, we know our footprint generally, or we know it well enough to know that this is a big part of it. We know we want to put some dollars towards it, but we're not quite sure how we're actually going to do it. That's the most common spot. And then we engage, right? So we say, okay, well, we've got different options. You can take a decarbonized drop-in material that's the exact same, or you can look at new materials that perform better, but that performance may or may not be relevant to your business. So let's talk about that, and then you can sort of walk through what that's going to look like.
Is there an example you could give us, like a case study of a company that you are working with at the moment, like just to sort of walk us through what they came through the door with and what they're now, exiting your business with, if you like, what are they getting from you? Could we look at something as an example?
We don't tend to break down individual customers that way because we try to, obviously we have a huge list of, Nestle, Pepsi, Danone, right? A lot of big companies are our customers, but, and this might be unsurprising for companies that have worked with them, but Pepsi, I'd say they're in the top category, especially early on, of level of organization, understood what they were doing, understood what they wanted, knew how to integrate new materials into their supply chain. And I think that makes sense for a couple of reasons. One, it makes sense because they're just an organization that operates that way. So they're a pretty tightly, or I shouldn't, tight's not the right term, at least in my experience. It's they have a pretty deep knowledge of their existing supply chain, and they have the humility that's required to just go figure it out if they find out they don't know something. And so our experience has been that they really are exemplary in the way that they sort of manage this kind of decarbonization program. And they were there way earlier. So they had a plan called the Performance with Purpose. Again, really early, like a decade before everybody else was getting on the bandwagon. And it was remarkably detailed in the implementation and how the decisions were going to get made. They published the whole thing to the world. And, I think people cared, but I think it was, I don't think when I looked through it the other day briefly, it reads like a how-to manual of how companies should probably start to address this kind of stuff. So I'd say they were excellent. They knew what they wanted. They partnered with us really early on. Nestle and Danone, by the way, also were early for us, and that they were very well organized. And I just don't know of a public plan that they had in the same way that Pepsi did. That is sort of, it just really tells you exactly how they're going to go about it. So they were obviously, if they're that early with us, big investors, signed large offtake agreements, really worked with us well. All three of them were just wonderful along those fronts. They're tough negotiators. Purchasing guys are hard, but they were great partners in the grand scheme and really understood what was going on. But they say, look, we know we need to solve PET. we can't really get there some other way. And you guys you're the game, right? If you're going to decarbonize PET, it's got to be you. And so we sit down and we say, okay, well, what volume is reasonable for us to be able to provide over what period of time? And capital projects take a long time in this industry, so we've got our first one coming on, mechanically complete, imminently, and sort of days. And so that length of time, though, says you've got to plan this stuff out pretty far in advance, right? They need to know what markets are they going to put it into. How it would take something like, call it 20 of our billion-dollar plants, which are our big ones, to supply just those three companies with material, right? Decarbonized material. And so you can't just say, okay, here's my order, like, let me know when it's going to show up. Like, it's a really detailed planning process, and you've got to figure out how do you build these assets and how are you going to allocate them. And so that's sort of the work that we do with them.
And this isn't a question about any of those specific companies you've mentioned, but we do hear a lot from some of our industrials about kind of the question around, will people pay for that greener material, that greener outcome? Where does cost come, would you say, in the ranking of demands or concerns? Is it, and it must be cost comparative, and that's our number one thing, or is that shifting at all? What are you seeing around that green premium concept and the reality of that at the negotiation table?
Well, I think there are two different time horizons that you have to talk about here, both relevant at the beginning. But the first time horizon that everybody always wants to talk about and should want to talk about is cost, not price, cost, and by that I mean cost of production, parity or better. And I think on average, that's important, right? So for it, obviously, if you're dealing with oil and gas, you're dealing with very volatile pricing. And so I don't think it's important that every single day you're beating the oil and gas cost, right? But I think in aggregate, over the course of a couple of decades, your technology is generally lower cost at the relevant volume than oil and gas based technology would be. So that's, I think, number one. And that's what people often really mean when they say cost parity. They want that. On the other hand, in the near term, I've got more people that want to buy my material than I can sell. And so as a result, since I can't bring online all of that capacity instantaneously, nobody could, it's just too much. That means that, if I've got more demand than I do supply, I've got to raise prices until my supply meets my demand, right? And so consequently, we do see premiums in the near term. And near term, I mean years. I don't mean like this month. We do see premiums. And I think those premiums will persist for a little while. And I think you see that in some of the other, let's call them like proxy renewable materials markets, like recycled PET. Recycled PET spiked in Europe, I think, to over 100% premium to virgin PET, and it's a worse product from a performance perspective. So we do see real premiums in the near term sort of meaning like this decade, I guess. But I think it's really important to have conviction that the cost of production over the long term will be, let's call it nearly the same or better than the oil and gas alternatives.
And one of the things when I was looking at the business that's interesting to me is before we came on to do the recording, I'd explained to John that we are mostly Northern Hemisphere focused at the moment, although we hope to change that soon. But you are quite active in Asia. I know it's a massive region to talk about, but I just wondered what's the kind of, when you think about the operations, the outreach, the discussions you're having there, like, what's your observation about how those Asia-based clients are tackling decarbonization? Does it feel very similar? Are there different constraints, different concerns? Like, how would you compare it? And I'm saying this in the full knowledge that people listening to this are banging their heads against the wall at me describing Asia as one market. Just go with it for the purpose of this question.
That's my very first comment was going to be, well, you really can't treat Asia all as one big market. But that's really true. But I'd say, and there are so many caveats to what I'm about to say, but what I would say is the emphasis tends to be more on the long term in Asia, in our experience, and so sort of oddly, the conversation about, you get the long term part right, and then the whatever we've got to do now to get there becomes easy, relatively speaking. I'd say in North America, and Europe's actually a little bit more similar that way too, in some ways. And then in North America, it's that long term stuff's great, but what's happening next week, right? What's that going to be? Which has its benefits too, right? So I think when it comes to deal execution, for example, and actually just getting the stuff done, man, once you agree on what you're going to do, you can really hammer it through in North America easily, right? It's just really hard getting aligned on the vision in North America. Whereas I think in Europe and Asia, to the extent that they're similar, sometimes it's easier to align on the vision, but then the muddling through to get to the like we've actually have a deal signed and we're working together part, that can be a little bit more challenging. But again, so many differences, right? I mean, I think I just lumped in Scandinavia with like Malaysia in my Europe is like Asia, right, comment, and I'm pretty sure there's some inconsistencies there. So,
all right, even within the UK, there
right.
would be arguments about lumping us all in together. So for anyone listening, don't be offended. This is just a way of talking about regions in a fairly short form podcast. All right. Well, as we're kind of coming to the close of the conversation, really the question that would interest me is to understand a bit about what's next for you. You've been through this 12, 13-year cycle of growth, publicly traded now, and expanding into different regions. But when you think about the kind of defining steps, the one or two things in the next couple of years that are going to be most important for you?
We're all deployment right now. So building capital projects, running the manufacturing plants that are produced by those capital projects, that's our life. We have other stuff going on. We always have new technology development going on, both process technology that is going to improve what we're doing, and also new products. Sometimes those new products are sort of, we think they're important, and so we want to develop them. And sometimes customers have come to us and informed us that they're important, and they want us to work on them. Both of those, but so those are both going on. But what's going to really make the difference is our execution on capital projects and our ability to manufacture effectively. Going back to that, chemical companies have to be good at a lot of things. You got to be good at building stuff, and or paying for somebody else to build it, right? You got to be good at buying somebody to build it, and you got to be good at running it. And so that's where we are right now. And
so you mentioned earlier that there's a facility about to go live imminently.
Yep, we have one in Sarnia, Ontario, up in Canada, and that's what we call Origin 1. And it's a plant that is some kind of uniquely sized. It's sometimes we call it a young adult plant, or maybe a teenager plant. But it's commercial in the sense that it really does produce commercial volumes of things. But we will probably never build such a small commercial plant ever again, which is good. It's good because it's good for it to be that size, because it means that we can supply really interesting commercial volumes to customers for new materials in a way that you sort of can't do off of really small like pilot plants, and you really can't afford to do off of a full scale plant. And it's also a size where we can make process modifications if we want to. So as we implement those two new kinds of technology that I mentioned, new product technology and new process technology, we can actually do that at this plant for the foreseeable future. So it's sort of a test bed for us in a lot of ways. But we've got a ton of demand for the product coming off the other side, so that makes it commercial too.
And what's the sense of pace of deployments? You said it's like all about deployment for the short term. What's your thinking around how many sites you can comfortably, confidently, deliver?
So I think the way this is going to work and obviously we sat down and we have a detailed plan about how we would deploy all this. And we communicated that plan when we went public, and, to the best of our knowledge, that's still what it looks like. But, if I step back and squint a little bit, the way this usually works is it goes faster in the medium term than you thought was possible. And the corollary to that usually is that it also goes a little slower than you think in the very beginning, right? Now we're on track so far, so we're trying to avoid the it goes slower part. But I do think I can see how it goes faster, and then in the long term it goes way faster than you ever thought possible, right? And so I can start to see the way that would come together in a conceptual sense, right? I see what that might look like. For us, I think deploying our own capital to build our own plants is the path that we put down originally and that we're pursuing. But I think that once this technology is up, even just maybe even at the OM1 scale, this plant that's coming online right now, I think that really changes the way that partners can engage and potentially deploy their own capital to go build plants of this kind of technology too. Because one of the really consistent things in the materials industry is once you have a best technology, it tends to take over the whole space. But there's so much capital that has to go in, even once it's clear that there's a best technology and that it's going to take over the whole capacity, it still takes 50 years to do that transition from one technology to another because the installed capital base is so large. And so I think that's, very unlikely that we will be the only company that deploys capital into this kind of technology. And so we're arranging ourselves in such a way that we can help support other players to do that, right? With technology licensing or whatever else.
Well, great. Well, look, thank you, John. I mean, really forcing you to define Asia as one region, uncomfortable moment, but thank you for going with it. And really good to hear about this whole journey that Origin has been on, but also, what this next year, 2 years feels like. It's a really exciting point in time to have caught you at. So thank you for joining us.
Great. Thanks for having me.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonizing the most energy-intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.